Okay, good morning everybody. How we's doing? Did everyone survive the animation? You're here, so you survived it. Hopefully with a couple new battle scars. Yeah? Yeah, right? We're going to dial it up a little bit today too. So, yeah. It's going to be pretty fun. We were kind of chatting before class started about going through our sequence. And as learners, and I think this is an important thing to remember, that you're right now, you're learners, okay? You're not makers yet, you're learners. You're still learning this pipeline. And our pipeline has a tremendous amount of steps associated with it. And it's overwhelming at times how many individual sequential steps that we have to go to. It really, really is. So, Dominic and I were talking, or Vincent and I were talking about, oh, everything's unshaded. Well, that's okay, because we learned a tremendous amount. I'm sure Vincent learned a tremendous amount in the struggles that he was going through last night as he was working on this project. And for me, that's what we're here to do, okay? So keep that in mind. Don't lose sight of the fact that you're here to learn this process. I think in other areas, we put far too much emphasis on creating portfolio pieces on every single assignment. Okay. Well, that's a good goal. The reality of the situation is not every assignment is going to be a portfolio piece, right? Sometimes we just have to have a project where we remember our sequence, we practice, we get good at this stuff. There's no expectation by anyone that you know all this stuff already, right? That's what you're here to do. You're here to learn it for the first time. So remind yourselves of that, okay? You're here to learn, okay? And everyone's going to be experiencing a lot of struggles as we learn this stuff, because it's not easy. It's not. It really, the guys and gals at Pixar and ILM, they make it look wicked easy, right? They almost make it look effortless, right? But the reality of the situation is that they're standing on 15 or 20 years worth of experience to make it look effortless. How long have you been doing this? Yeah, a year for some of you guys, a semester, right? So it's a very long path. Don't forget that. All right, this week we're going to continue our conversation about rigging a little bit more directly and start talking about deformers. So let's just jump over to Canvas here real fast and take a look at specifically what we're going to be throwing down. For those of you that came in a little bit late, we're going to be looking at all of our animations towards the end of class today, or I would like to. I got to remember my password. Oh, before we get started today, one small announcement. At some point this morning, and they didn't say in the email when, but there is going to be a test of the emergency alert system in class, okay? So keep that in mind. I'm really kind of hoping it's right smack dab in the middle of class, because I want to kind of see how this, this rolls out. Are we all going to get a text message? Are all of our phones, kind of like the Amber Alert that we had earlier in the week? I'm really kind of curious to see how this works. Don't be surprised if you don't get the message. I believe it's something you have to opt in for, and I don't remember where you do that. I think I've been working here for this is my 11th year, and I think I opted into all the emergency stuff and notifications when I first started teaching, so I don't remember where you have to go to turn it on. But just FYI, the building isn't on fire. There isn't like some cataclysmic, life event that's happening. It will just be a test. So, all right. So, as I mentioned earlier, today we're going to talk about deformers. Okay, deformers, and we're going to roll into, kind of a small little reminder of how our constraint system works. I have a really fun assignment for you. I'm kind of excited about it. It's something that I think is going to be pretty fun. It'll act as a really great culminating experience for our conversation today. It's called Cannon Blast. So you're going to be making a cannon. You're going to be modeling a cannon, or you can find a cannon or something that looks like a cannon. Shoot, you can even use some of those mesh presets that we used for our alien invasion rig, our turret rig. You can use those too. I really don't care. I want to show you some kind of advanced modeling things. If you haven't taken the 3D modeling class yet, you definitely leverage the power of some of those presets that are inside of Modo. That will get you going on this assignment. I want to show you some of my thinking when it comes to the modeling of something like a cannon that will hopefully kind of change and continue to sculpt your modeling pipeline. Some ideas that we just didn't talk about in GCOM 402 that I think are really kind of important. But when it comes back to the animation and the rigging side, we're going to be taking a cannon and we're going to be creating a whole series of deformers and constraints that allows for us to produce the illusion of kind of like a really fun cartoon cannon blast, right? So we're going to have a tremendous amount of squash and stretch on the cannon barrel. Maybe we'll have some, we'll start to suggest that there's some sort of cannonball on the inside that's starting to bubble and warp our cannonball as it gets forced out the front. It should be a pretty fun assignment. I think you're going to be into it, and it's going to give us a great opportunity to learn a lot about deformers, because deformers are really the root, the foundation level idea for our entire character rigging system. Deformers basically allow us to take a mesh and bend it. Okay, if you look at all the constraints that we were looking at over the past couple of weeks, we were able to move and rotate and change their direction. But when it came to the interior, surface, the interior surface shape, it really didn't change, right? The wheels maintained their original shape. The turret always maintained its original shape. The barrels never bent, right? The volume, the shape of our character never changed. Well, that's going to change today as we start to introduce the idea and the role of deformers into our rigging pipeline. I think you're going to find that it's pretty easy, but we're going to add a couple layers to make it really powerful. The moto rigging system is pretty great. I'm a big fan of it. There's a lot of really good stuff in here. And one of the elements that I particularly really enjoy is its accessibility. It doesn't take, you don't have to have a PhD in computer science to run the damn thing, right? And that's the case in a lot of other packages. I'm looking at like Maya. Man, the rigging tools in Maya are from like 1996, right? It's like a time warp, right? Doctor Who shows up. Anyways, okay, let's get into it, all right? Actually, would you mind hitting the lights, maybe the first two on the bank over there? That'd be helpful. What? No, you can leave the door open, that's fine. No, they don't, actually. In all honesty, they're wonderful. But, I'm an Autodesk subscriber. And so every 6 months or so, they always send out a survey for an opportunity to provide some feedback. And every single time, I write at length about their interface, about their interface and about their workflow. It's definitely more leaning towards the engineers in the group than the artists of the group. So there's definitely some room for improvement. But they have some good technology. They actually they have probably some of the best technology in the business. It's just really hard to leverage and use. And Autodesk, maybe if you're listening to my live stream, they said, hey, do you want us to contact you? And every time I say, yeah, please contact me. Here's my email. Here's my phone number. I want to talk to one of the developers. Never once have heard from them. So maybe they don't like my feedback. I don't know. I try to be nice. Yeah, that's where I was like, don't talk to the moto guys and gals. All right, so let me just show you kind of where we are, because we've been talking a lot about constraints over the past couple weeks. We've had entire assignments dedicated to constraints. The Alien Invasion is a really great kind of culminating experience all about constraints. Our entire rigging system for those animations were built around constraints. But as we were talking just a moment ago, when we add in constraints, we never actually bend and deform the system. And this is the example that I was using a couple weeks ago. You probably remember this, the rings. Just make a couple rings here real fast. Of course, me being me, I have to have everything centered because that's just the way I roll. And it's good modeling practice as well. Let's just duplicate this. Oops, I don't think I hit the word duplicate. There we go. All right, so here's my two rings. This is where we were last time, right? Does anyone remember how we can constrain these two together? Let's go to the Setup tab real fast, get to work. Yeah, hold on one second. I'm going to change a couple things so we can see what's going on. Okay, so here's my two rings. I want to constrain them together. Now, there's a selection sequence and an order that we need to remember and follow as we go through this process, right? Let's pretend that I want to have, you know, the big ring rotate, and I want the other ring to rotate as well. How do we do that? You could just parent it, right? And what we're doing when we parent things together, let's just get really specific. This is our big ring, biff, big ring. This is our small ring. Okay. So you could just parent them together, right? Boop, like that. That works, because now when we grab the big ring, the small one also rotates, which is pretty cool. Okay, and that is actually a constraint, a parent-child relationship. It's one of our simple constraints that we can apply to all of our objects. But what if I just wanted to rotate but not move, right? Because when we parent things together, we're basically overriding the transforms, all three transform channels, right? Position, rotation, and scale. Okay, we're taking all three of the parent are overriding all three of the child, right? What if I just want to do rotation? You got it.
So it'd be the inner item, and then the outer item, and then the whichever constraint you want.
You got it. So we're over here in modifiers. Technically, inside the system, I believe these are called constraint modifiers, if we're trying to be accurate. But here's that rotation constraint. Okay. With that applied to our scene, of course, naturally, the big ring, when I spin it, will rotate the small ring, just like we had before with the parent-child relationship. But it's just the rotation properties, okay? I can move the big ring over there. The small one doesn't move. We can do that, right? So these constraints allow us to get really specific. Instead of all three, position, rotation, and scale, now we're doing individual groups, which is pretty neat, right? From big to small, if you will, okay? So constraints allow us to very quickly start making some simple relationships between the animation channels, and that's really what they're doing, right? We're taking all of this stuff, okay, all of our animation channels, okay, and we're sending and piping all of that information from one item to another item, right? We've been doing a lot of this over the last couple weeks, but on, like literally on the surface, what isn't changing are the shapes of our characters, right? This ring and that ring are fundamentally the exact same shape and form as they were originally. I want to start to go in and bend these shapes and give it a little bit more deformation across the surface of our geometry. And what we need to start exploring are deformers. Okay, deformers are the underpinning, the foundation for the entire character rigging pipeline. Because if you think about it, let's put this into practice just for a second. Okay, we're going to fast forward to next week. I'm going to give you guys a character that's standing at the T-pose. Right, this is what's called the T-pose. Okay, I'm going to give you guys a character. Single mesh item. All the geometry is going to be encapsulated on that single mesh item, right? How are we going to be able to move this character when it's all on one mesh item, right? The answer to that question is deformers. We need to have some sort of system that allows us to bend the geometry around very specific places and at very specific rates to get the illusion of a little puppet coming to life, okay? If you think about the big picture idea, we're almost kind of going back to the stop motion animation days, where we create a metal armature skeleton on the inside, and then we have foam latex, you know, bendable material on the outside that allows our character to pose to make it look like King Kong is going up the skyscraper, right? Which I feel we all should watch, right? You guys ever seen the original King Kong? It's actually pretty amazing for... Do you have the DVD? Not the Peter Jackson King Kong, which has its moments, right? But the original King Kong from, I think, the 30s or something like that. Yeah, it's pretty fantastic. It's pretty fantastic. And it's just good art, right? So let's start talking about deformers. And I hope that you follow along. This isn't something that you can learn by osmosis. I want to be just using some very simple shape primitives to get us going here, okay? Like our constraint system, there is an order of operations that we need to follow, a sequence, in order for all of this jazz to be wired in and piped in together. So here's what I'm going to do. Actually, in all honesty, I'm just going to create a new project so all of my ring stuff can just go away. And inside this new project, I think I can't make it any more simple than a unit primitive cylinder. So let's do this. So if you've noticed up here inside of this version of Modo, we have access to a whole series of popovers. Okay, so these are all our modeling tools, our UV mapping tools. These are our retopology tools. So we've been chilling over here. Excuse me. There's our schematic. I hit the wrong one. It's that one. This is our setup tools. Okay. So if I click on the cube, I can very quickly hold down Shift, click on the cylinder icon to get a unit primitive cylinder inside of my scene. Okay. So there it is. I want to start to bend and deform this unit primitive cylinder to create maybe what could be an arm or something like that. We're not going to add any constraints. We're going to add a whole series of deformers first. Okay? So to find our deformers, let's go back into our setup tools. Okay? And there's a whole dedicated section inside of our tool tab called deformers. And there they all are. Here's all of our deformers. There's actually more than that. There's pretty neat. There's some really powerful deformers that come in this list. Okay? We're not going to go through all of these, but I do want to show you some rock stars and how they work, and how we can maybe use the deformer system to create a really complex rig out of a whole series of simple moving parts and pieces. Okay? The first one that we're going to take a look at, we're going to start with an easy one. It's going to be called the bend deformer. Okay? I'm choosing to start with the bend deformer because it's really easy and simple to see what it's going to be doing in the effect of the deformer and the effector on our mesh. Like everything inside of Modo, the thing that we need to do initially is ensure that our object in item mode, okay, because remember, our entire animation rigging system is an item-based system, is selected. Now, if we have our item selected, the target, the home for this deformer selected inside of our scene, the deformer will automatically get applied to this shape. Now, if you don't have it selected, it's not the end of the world. We'll just have to go into the schematic and kind of wire some stuff together. But make it easy on yourself. Select the object that you want to influence first, and then you can activate the deformer. So this deformer, the bend one, is wicked easy. Okay, so we're just going to click on the bend, and you can see that a couple things have changed. Now, I think I have all of my locators in my scene turned off. I sure do. So got to have show locators on, because then the interface for all of these deformers is going to pop up. Ta-da! Okay, so let's talk about what we're seeing inside of the interface now. We have a dotted line coming from the origin of our three-dimensional scene that's terminated in a small cube. In addition, over in our item list, some things are starting to change, right? Inside the cylinder item, if we click on the little disclosure button here, this is the actual deformer itself. Okay? We'll come back to the role of these green cubes here in a minute, but this is what's doing the heavy work, the heavy lifting of this entire system. This effector down here is basically that dotted line. It's kind of the interface for the deformer. It tells the system how to bend and change our cylinder shape along a very defined path. Okay? We'll come back to this bend deformer here in a minute, but for right now I'm just going to close it up and focus all of my energy on this effector, because this is what's doing a majority of the work. Okay? So with our effector selected, and you can select it in the item list or simply just clicking on it inside the three-dimensional scene, the Properties tab is going to give you everything that you need to do, or everything that you need to use to start to bend your little tube here. Okay? Now check it out. I'm just going to simply change the angle. There we go. And you can see what's happening. Now we're bending our shape. Okay? Now on the surface, you're probably saying, cool, Pat, how is this different than like the bend tool over in our modeling tool set? How is it different? You can keyframe it. You can modify it. You can change it after the fact. This is a very, very extensible system. And in the sense of it, character animation and character rigging, we're never going to be like freezing our mesh. We always want all these deformers to be live so we can continue to deform and animate our little puppet. Okay? A lot of folks, they use the traditional deformers as modeling tools. I use them a lot. You can actually freeze out the mesh. It's a great way to kind of iterate non-destructively on your model. So we select our item, we add the deformer. The effector is going to give us the interface, if you will, of our deformer. But let's pretend just for 1 second here that we need to make some changes, because I have some big-time problems with my mesh. Okay, where is it bending my little cylinder from?
Center origin?
Yeah, at the origin of the scene. Now, the center of the mesh when I created this unit primitive was placed at the origin of my scene, as was the bend effector when I created it, okay? But I don't want my bend effector to start in the middle of my tube. I want it to start down here. How am I going to do that? Interesting idea, right? Now, here's what we don't need to do. We don't need to delete the effector, okay? A lot of times that's like, oh, I want to start over. You don't have to start over. We just need to make a change. Now, when we're working with rigged systems like this, when we're having an effector and an influence system deforming our three-dimensional mesh, it's darn near impossible. And just simply, I'm going to put my angle back to 0, okay? It's darn near impossible to go in. Let's see. It's going to make a liar out of me. Yep. Well, in this case, it is allowing me to do it. But this is not the correct way of doing it, right? Because ultimately, let's see. Oops, I clicked off it. Will it bend now? Yeah. So you can move it, but there's a better way. And the correct way of making changes to a rigged element is by going into what's called setup mode. And this is something that we're going to be going in and out of quite frequently. Setup mode basically allows us to adjust often what's referred to as the bind pose, right? Think of the bind pose as the original state of our mesh when we start adding these rigged elements into it, right? It's the original character at the T-pose inside the scene, undeformed, uninfluenced by the rest of the rigging system. When we go into setup mode, we can make root changes to our rig and not have it completely screw up our mesh, okay? So whenever we need to make a change, here's what we should do. Enter into setup mode. Setup mode can be found over here inside of our interface. I'm sure there's a keyboard shortcut. I've chosen not to memorize the keyboard shortcut because I need to make sure that mentally in my brain, I understand that I'm in setup mode and that I'm out of setup mode, right? Manually going over and clicking on a button is a great way for me to remember, oh, I'm adjusting the rig now, I'm not adjusting the animation. So we go into setup mode. You can see that in the interface, our world changes ever so slightly. The guys and gals down at the Foundry have given us this wonderful yellow border around our viewport. If you look very carefully, the background color changes its hue ever so slightly. So some nice visual reinforcers that we are changing, or we're in an environment where we can change our rig. And the best place to do this is over here in setup mode. Now, the reason I like to do all of my edits to my rig inside of setup mode is that I don't have to worry about it messing up any sort of future editing operation, right? By returning it to the setup, to the bind pose, I'm basically turning off the influence of the rig. I'm separating it from the mesh, okay, and allowing me to make changes to each one of those things independently. All right, so I've changed the location of my effector. I'm also going to change its length. I don't know what the length's going to be, so I'm just going to do it visually. Something like that. That's pretty good. And then when I'm done with my edits to my rig, I'll exit setup mode. Now, I'm free to go and make changes to my rig. Okay, and now we're bending from the start all the way to the end.
So once you have it in setup mode, then you can just select the bend effector and fire off the move tool. But it's preferable to do it in the setup mode and not in the regular viewport.
It is, and let me show you, now that we've made a change and we're talking about setup mode, let me show you another reason why setup mode is the preferred way of getting this done. What if we've applied the effector, we've bent my little cylinder here, and I go, oh man, this is the right angle, but I'm not getting the look that I'm after, right? I don't want to monkey with the angle. Maybe that angle is influencing another part of my project. I just want to change the length of this effector. Well, at the moment, it's kind of hard to visualize the length of the effector when the character is deformed like this, right? It's like, how high does it need to be in relationship to the root mesh? Well, if we return to setup mode, okay, once again, we've kind of turned off the influence of the rig, and we're able to edit the root components of that rig without actually changing the animation, right? Our character goes back to the bind pose. I'm free to make a change. I'm going to leave that angle at a negative 100 degrees, and let's do this. Let's just change, let's just change the location of it. Okay. So now it's only going to bend from kind of the middle-ish to the top. Once I exit setup mode, You can see how it changes, right? So setup mode really deactivates the influence of any deformer on our character and allows us to make raw root level changes to the rig, okay? It's a great, great powerful system. I'm happy that we can kind of toggle it on and off, okay? This turns into a landmine, though, if you're not aware of its function, because once you click on that setup mode, you're not going to be able to animate your character, right? Because setup mode is really, really, really built, custom made to change a rig, not the animation, right? So keep that in mind. All right. Pretty cool, huh? Pretty neat, yeah. There's a whole bunch of these deformers that we can add into our scene itself. The bend effector is a great way for us to kind of get started. Now, since we're talking about kind of working with these deformers, let's talk about how we can control them a little bit more directly, okay? All right. I'm going to grab my effector here, and let's put it back to 0. And I'm going to go into setup mode and return the base of my effector to the base of the model. There we go. And I'm using my snapping system just to give me a little bit of accuracy here. That's pretty good. I'm liking that. I'm going to turn on the visibility of my wireframes. Oops, wasn't selected. That's why. There we go. All right. Okay. So here's where we are. I want to go in and start to customize this a little bit. Okay. Maybe I want it to bend. That's a great idea. But maybe I want to have certain areas bend at different rates than other areas. Okay. So let's talk about that just for 30 seconds. Hold on one second. I apologize. Okay. Emergency at home. Many apologies. Okay. So I want to be able to continue to influence the power or influence the role of these deformers on our meshes, okay? And we have a really great system. Some of you have already seen this system in other areas. It's called weight maps, okay? Weight maps are going to modulate the influence of a tool. If you think about these deformers, they're kind of like a fancy hammer, right? Think of it like a blowtorch that's bending our pipe into a certain shape. Well, what if we can influence where that blowtorch is going to be melting our pipes, right? That's what a weight map is responsible for. It influences or it determines the influence of a tool on our mesh, okay? Specifically on a whole series of verts. Have you ever wondered, if you've done some UV mapping in your lists tab, have you ever wondered what this weight maps section is for, right? Well, that's what, this is the area inside of Modo that allows us to create new weight maps and then see their influence on the tools themselves. So let's just do it real fast. I want to create a new weight map. Let's give it a good name. And I think for this example, what do I want? I want to use, maybe I only want to bend, maybe I only want to have that top row, the top 2 rows of my mesh get bent. Okay? I don't want the entire tube to get bent. I just want the top 2 specifically. We can't get a tremendous amount of accuracy using these deformers. So the weight maps allow us to go in and on a per vertex basis define the influence of these effectors, right? So I just want the top two rows of polygons to be affected. Okay, so I'm creating a weight map called top rows, and poof, it's red. Okay. Now, when it comes to working off of weight maps, what we're working with here is a percentage of influence. I apologize. We've ordered our big brand new rolling whiteboard. Hopefully it will be here soon. I miss having something that I can draw on and explain things on the board. But big picture idea, we're doing influence. So the range of values that we're going to be working with is 0 to 100%. 0 to 1, okay? The tool is influencing this vert at a value of 100% or 0% or any value in between, okay? Whoops. In Modo, 100% is communicated as red. Okay? So right now, the vertex weight of every single vert on this model has been automatically assigned to a value of 100%. So when I bend my tube, that bend effector is going to influence every vert 100%. So it's going to take 100% of the deformation from the effector, right? So red is 100%, and you're going to see here in a second that it's kind of, I don't know, it's a pale green, perhaps, right? I'm just going to say it's green. Green is 0%. Now, which parts of the mesh do I want my bend effector to influence? The top two rows, right? So I need to go in and transform the vertex weight values for all the verts below those top two rows to 0%. Okay. Luckily for us, it's really, really easy to do this. Okay. You can do it in any sort of component selection mode. Okay. So I'm going to grab all of this jazz. I'm holding down the middle mouse button so I select through. I'm going to leave the top two rows at 100%, and I'm going to change the weight value, the vertex weight value for all the other ones to 0%. There's a number of ways that we can do this, but here's the easy way. Okay. At the top of the screen, we have a Vertex Map Pulldown menu. You probably have never gone into this area. You know, for most classes, it's not something that we really focus on, but for the rigging pipeline, vertex maps and weight maps now become a central part of our rigging system because it defines which parts of the mesh are going to be influenced by certain deformers. So down at the bottom of this long list, okay, dun, dun, dun. Oops, I passed it, weight tool. Okay, let's turn the weight tool on. You can see over here that the vertex map weight is going to be set to 0. So if I just click, ta-da, there it is. Okay. Now, I said earlier that it's supposed to be green to red. This is a viewport property that can be changed. Right now, we're only seeing the 50% to 100%. If you hit the O key to bring open your viewport properties and turn off show weight maps, okay, now you're not going to see anything until we actually change our viewport properties to look at the raw weight map data. Okay, so there's two ways to examine all of this stuff. Hold on one second. All right, so as a small, simple reminder, there's two ways to view your vertex weight maps. Okay, there's a viewport property, right there, show weight maps, bloop, okay, and that will show the weight map if you're in the default viewport shading model. Okay, if I have it deselected, it's not going to show us anything. If I select the weight map from my lists environment, it'll show me the weight map. Okay. So that turns it on and off, okay? Or that selects the weight map so you can see it. Another way, which is the way that I like to do it, is you can change your viewport shading style to vertex map, okay? And now it's basically going over here and it's looking at whatever's in this container and it's going to show the weights of what's in here. And if I select my top row's weight map, you can see what's in there, okay? And these things are highly editable, which is another reason we like weight maps. We're not like hard coding and freezing in the deformation to our verts. We're doing it with the weight value, which we can change at any time. So let's go in and start leveraging the power. Change my shading model back to default. Return to my bend effector. Or excuse me, let's go in and start changing how this bend effector is going to be used inside of our three-dimensional scene. okay? Because now I want to use that weight map, right? I only want to bend the top 2 rows a little bit, okay? Instead of looking at the entire mesh, I want to have my deformer, okay? This thing, remember how I said we're going to come back to this in a minute, okay? I want the deformer to not use the entire mesh. I want the deformer to use a weight map, okay? Well, which weight map? The one that I created, top rows, okay? Now watch what happens now when I rock my bend deformer. It's kind of a silly example, but I think you start to see the power of these weight maps. We're now controlling very, very accurately how the deformer is going to influence our geometry, right? We are telling the computer now what's being deformed and at what rate. Now this looks like garbage, okay? We're going to fix it. Yeah?
I have a question. Can we go another way? Like, for example, we have this item, we divide it into different pieces, and we place locators in each piece, you know? And we move the locator, and the pieces inside the item will move.
They'll move, but they won't bend. And that's the power of deformers, is that we're physically changing the shape of our original mesh. We're not just moving and rotating them. Now we're bending them in the middle in some really unique ways. So your suggestion is going to, unfortunately, not bend your mesh. Yeah. So it's over in your item list, okay? And it should be a child of the object, the item that you attached it to. Yeah, top rows right there. Other questions? Yeah.
Got a little bit lost while I was trying to select the polygon.
Yeah, so, and that actually kind of brings up my next point. So we need to make some changes to my weight map because this looks like garbage, right? It does not look like this is very bad, okay? I want to be able to go in and change my weight maps, which is why this is such a powerful system, because I can now go in and continue to influence the deformation of my rig after it's been deformed, right? So let's do it real fast, and this will answer your question as well. I'm actually going to go back to setup mode, which puts everything back to its undeformed location, right? And let's change my viewport shading style to vertex map so I can see my weights, okay? I got my top rows weight map selected. Changed my shading style from default OpenGL to vertex map, okay? And now I'm going to make some changes, okay? So you can do this at the polygonal selection level. I'm just grabbing some polys here. And then to change it, it's the weight tool. Shift W, I always kind of remember it like that. Shift W. All right, and now we have to tell it what percentage to assign this weight to. Just for giggles, let's put it at 50%. And you have to click. Some people change, they forget to click. Okay? Once you click, it assigns the weight. I know it's kind of hard to see, but we're now starting to establish a gradient of colors across the weight map itself. See at the very, very top, and I understand that it may be difficult with this projector. Hopefully it'll be easier to see on your local computer. It's pure red. 255, 255, 255, right? Or I guess just 255 in the red channel. I said that wrong. Pure red, where the weight value is 100%. And now, see how this is a lighter shade of red as we're heading towards that paley green? Okay? So that's another kind of good visualization of how all these elements are working together to deform and bend my character.
I have a question.
Sure.
It's on my end. I'm getting it when, so I have it set up. When I go to change the angle of the bend effector, it's sort of, it's like warping I have the top 2 rows set to do it, and the top row is kind of bending separately and staying static.
Uh-huh.
I don't know how to explain it.
Well, let's take a look. I think you're student 3, Dominic. Yes. Let's check it out. All remote desktop does not want to work today. All right. Okay, show us your problem. Yeah, no, that's what it's supposed to be doing, right? It looks like garbage, right? Because only those top two rows are receiving 100% of the angle of our bend effector, right?
So when it like sort of angles up and then angles up again, that's
Yeah, because right here. Yeah, it just looks like garbage, right? Because we're basically going from we're going from 100% to 0% on the next row, so we're getting this really weird clipping. Yeah, that's what you should be seeing.
I'm still, I don't know how you got it to actually move. I must have missed something.
Okay.
And the two things that I set, they're separate, so
Okay. What computer number are you, Melissa? 7. Let's take a look at where you are. We'll get you caught up here. Or not. There we go. Okay, cool. So Melissa's doing it a little bit differently, right? She selected the middle band and made its value 100%. Okay, I like it. So bend your effector. Yeah, select your effector from your item list. Should say bend effector. Now look at this properties tab. You're in the lists tab. Yeah, and you change the angle. This will be fun. Oh, okay, 2 things. Now, it's bending across the entire mesh. Let's, we only want it to bend using the weight map, right? So there's one small change that we need to make. Does anyone remember where we need to go to make that small change?
the bend item.
Yeah, we actually go into the deformer itself, the bend deformer, which is the green cube underneath. Yeah, that's the one, right? So we have the deformer, which is actually doing the heavy lifting, right? And then we have the effector that kind of tells it which direction to go, okay? So, yeah, there you go. Now, what did you remember the name of your weight map, Melissa? Okay. Go back to your deformer, your bend deformer, because we need to tell it which weight map to use. Oh, yep, you right where it says type weight map. That one right there. Now give it go to the one right below it. Click out of there. Yeah. There it is. Great. Now go back to your effector and give it a good old bend. Let's see what happens. You can't really, unfortunately. You have to do it over here. Change the angle. Now that should be as expected, right? Because if you go back, let's check that out. This is kind of an extreme example, but it illustrates the idea, right? Because what part of her mesh is taking the influence of the effector? Just the middle, just the areas that had a weight value of 100%. The top and the bottom, where the weight value was 0%, was not taking any of the influence. Crazy, right? So this does not look good, right? And even mine does not look good. So we need to have a system in here that allows us to maybe make a gradient of changes, okay? We're going to continue to leverage this power, okay? So even mine looks like garbage still. Let's do a really defined kind of example here. I'm going to put my angle of my bend effector at negative 90 degrees, okay? Because now we can mathematically start to break this down a little bit. Over here, the polygons that had a weight value of 100%, what degree are they getting bent to? 90, right? The polygons that had a weight value of 50%, what degree are they getting bent to? 45, okay? 100% the influence of the effector, 50% the influence of whatever we put in, 0%, okay? I want to start to maybe blend these a little bit and create a gradient of values. I don't want to have to go from 100 to 50 to 0. What I would like is to go from 100% to 0% and let the computer automatically figure out the gradient of values that needs to be placed down on my geometry to give me a smooth kind of articulated bend, right? So let's add in another layer here. I'm going to go back into setup mode and simply, I think I'm just going to nuke all of these values, right? I'm going to grab all of those polygons, and using the weight tool, I'm going to assign their weight value to 0%, basically turning them off. Okay? So here's my weight tool. Let's put the value to 0%. Bloop. And we're on our way. I love vertex maps, right? These weight maps allow us to non-destructively influence the deformation of our characters, which is awesome. We're not hard coding it in. We're using these weight maps to determine it, and it gives us a tremendous amount of flexibility in the future, right? Yeah. You go back in time, hit undo a couple steps. There it is. So I just selected all the oops. Come on, fingers. There we go. Okay. So I just selected all the polygons that I want to influence. And I'm just going to apply the weight tool again. Shift W. It's also under the Vertex Map collection of tools way down here towards the bottom. The weight tool is going to assign a weight value to the selected vertices. Okay? And we just got to make sure that we set it here first, and then click in the interface to apply the values across all the selected components. All right, so now I'm kind of back to square one, right? I've turned off the influence of my bend effector on the entirety of this shape, right? Because every vert on my cylinder is at 0%, so nothing is going to get bent now. Nothing's going to receive that data from the effector. All right, so now let's start to talk about how we're going to apply that gradient, okay? We're still going to use the weight tool, because the weight tool is our method to go in and to assign weight values to the selected geometry. But we need to add a new layer that allows us to create a gradient. Now, in other packages, you have to go in by hand, and paint, the gradient. Pat, don't play that, okay? I'm not doing that, right? That's just not going to happen. What we're going to use are what's called fall-offs, okay? Fall-offs are a global system inside of Modo that's going to modulate the influence of every tool, okay? It's going to apply a gradient to the influence of every tool. And when I say every tool, I mean every tool. Even the rotation tool, the move tool, the scale tool. It's a very wickedly powerful system. But we're going to use that to influence how the weight tool is going to be generating a gradient for us inside the system. Okay, so once again, I want to select the polygons that I want to mess with, which is those in there. I want it to be 100% up here at the top, 0% down here at the bottom. Okay? So the first stage is selecting the geometry that we want to influence. The second stage is to activate the fall off. Okay? You're going to find at the top of your bar here. Here's all of our fall offs. There's a whole bunch of them. Some of these I use every other modeling sequence or just every other step. Some of them I honestly don't even know what to, like the curvature one, I just don't know what that does, right? They keep adding fall offs, which is kind of nice. But let's start with the linear fall off because I think it's the easiest way for us to work, okay? The linear fall off, once we activate it, we got to click inside of our screen. The linear fall off is going to allow us to create an area of influence. I'm all zoomed in, so it's wigging out. Let me turn it off and then back on again. Okay. The linear fall off is going to allow us to create a range of influence across our three-dimensional scene for our tool. Okay. Now I've kind of placed it to the right side of my mesh so you guys can see the interface of it. You make this little triangle, or it makes this little triangle. At the small point of the triangle, this is 0% influence. Okay, so whatever tool that I fire off at this area inside of our three-dimensional scene, we're going to get 0% influence of that tool. Okay, so if I was to fire off the move tool and I wanted to move all of these polygons to screen right, these polygons down here wouldn't move because the fall off is saying in this area is 0% influence of any tool. The tip of the triangle, 0%. The wide part of the triangle, 100% influence. Okay. Let's see what this does when we fire off the weight tool. So vertex map, weight tool. Now I'm going to put the weight at 100%. Now watch what happens when I zoom in and just click. So I'm applying a 100% weight value to all the verts inside of my scene. That's what the weight tool is doing. But because I paired it with a fall off, that fall off is now modulating the influence of that tool, right? So up at the top, 100%, so it's receiving 100% of the tool properties that I created, right? But at the bottom of the fall off, it's receiving 0% of whatever tool properties that I inserted, right? I told it to be 100%, but the fall off is taking it down to 0, okay? Gradient values, we're modulating the influence of a tool across a zone. Yeah?
And once we turn the fall off, it stops affecting that area, but it keeps whatever was affected.
You got it, yeah. You got it, right? So, and I think it's a cool idea, right? It's pretty neat. We got to make sure we turn our fall-offs off when we're done with them, okay? Because they're going to continue to influence every single tool. Let me show you this, right? When I say every single tool, I really do mean every single tool. I've just fired off the W key. This is the traditional move tool, right? Okay, that fall off is modulating the influence of the move tool, right? Down there at the bottom, at the tip of the triangle, these verts are not moving at all. They're receiving 0% of the influence of the move tool, but up at the top, they're getting 100% of the influence of the move tool. So it's every single tool is influenced by the fall-offs. Point being, once you're done, just make sure you turn it off. That way, the tools work as you think they would. Question? I see a... So that triangle is kind of strange. It really is. And let's go back to the creation or the application of the fall-off, because it's a little bit of a... It can be a little bit of a thing from time to time. Now I have the move tool on. Let's try this again. So when you turn your fall off on initially, the first thing that you got to do is left click and drag, okay? Because left click and drag is going to create that little triangle, okay? So left click and drag. I've learned from my experience just that wherever I begin, that left click operation is going to be 0%, okay? What computer number are you again, Melissa? I'm sorry, I don't remember. 7. Let's check it out. That's okay. This is new stuff. This is tough stuff. Okay. Show me what you're doing. Don't hit Shift W yet. Go ahead and drop your tool real quick. Activate. Let's go to activate the fall off now. Fall off, linear. Now, in your 3D scene, left click and drag. There you go. Cool. Cool. Now you're doing it. That's right. Okay. What we want to do is that we want to put the tip of the triangle kind of in the middle part of your mesh. Now, I think it's snapped or something. Yeah. Let's do it again. Yeah, start. The tip is 0%. So the small part, yeah, there you go. Now you can edit it after the fact. If you look real carefully, try it again. If you mess up or you're super interactive, okay, don't do anything yet. You're doing good here. Zoom in a little bit on your mesh so we can get an up-close view of what's going on. Now look very carefully at the ends of our fall-offs. We have transform handles. So if we messed up in the positioning of our fall-off, we can just change it real fast, right? Yeah, there you go. Wonderful. I try to do them in orthographic views as much as I can because I get a tremendous amount of accuracy. So Melissa, what I would suggest maybe changing your view to like the front of your scene. Yeah, and now we can see with grand accuracy where the position of those fall-off handles need to be to get the result that we're after. Yeah, well, they can be in the middle, okay? Grab the tip and drag it up. That's it's right there. Yep. Keep dragging, drag it so right about there. And then grab the other one and drag it towards the top, right? I always think of it like this. The top is where it's going to get 100% of the tool. The bottom is going to get 0% of the tool, okay? So that's looking pretty good. Now fire off the weight tool. Did you fire off the weight tool? Do it again. I don't see that the tool is on. Okay, there we go. Change your value to 100%. Okay, now click in your interface. Ah, there it is, right? Yep, you're welcome. Okie dokie day. So let's see how this influences my mesh. Okay? Yeah. Ta-da! Still working pretty great. Okay? Yeah.
So I have it set up like that, and I'm getting it still just moving the top 2 rows of polygons.
Okay. Let's take a look-see. Okay, let's go to the actual deformer itself. Okay. Do me a favor, go into your Lists tab, and deselect top rows. Don't delete it, yeah. Yeah. Click back on it. That's interesting. Let's go back to the bend effector. Yeah, and let's examine its properties. Yeah, everything in here is looking okay. You know what you could do, and this may be a way to kind of reset the deformation system. If you go back to the actual deformer, the bend deformer, change its influence back to entire mesh, its type, I'm sorry. And then change it to weight max. Yeah, test it real fast. Or, there we go. Now we're getting it. It's probably just stuck. Maybe the database didn't update or something. Yeah. Cool, huh? Say again? Yours isn't Ben. Okay, let's see. 3 or 4. Let's see how you're doing. Maybe. Here we go. Okay. So, actually, it is working. But let's do this first. Okay? Let's drop your tool, because I can see they have the move tool working. And I also would like you to turn off the influence of your fall off. The linear fall off. Yeah, you were in the right spot 2 seconds ago. Yep, turn it off. Now grab every single polygon on your mesh. And let's transform the weight, using the weight tool to 0% with the weight tool. Then click. Yep. Click in the viewport to apply the tool. Did you click? Try it again. 0. And then you're clicking on the geometry right now? There we go. Yeah. Got to physically click in the viewport to apply the influence of the tool. Okay, cool. So now, let's go back in and add that fall off again, that linear fall off. Yep. Now make sure you're selecting all of those pieces. Yep. There you go. Okay. Where do we go in the interface to apply the fall off? Or to activate the fall off, excuse me? Fall off first. Fall off first. Yep. Cool. Cool. Keep going. There it is. Good job. That worked. And that's how we create a gradient of influence across our mesh. Pretty neat, huh? It's actually doing it, though, right? Yeah, it's actually doing it. If you look very carefully, down at the boundary of your fall off, well, here's the way to test it. Drop your selection. Okay. Now click on the background to drop your selection. Okay. Now I can still see that you have your fall off active. Run the move tool. Just hit the W key. Yeah. See where the fall off is, the verts that are below the fall off are not moving, right? And the verts that are inside that range are accepting 100% or a gradient of values across the mesh. Now, Evgeny, what I would recommend that you do, hit undo a couple stages, get your mesh back to looking cylindrical. Turn off your move tool and turn off the influence of a fall off. Now, run your bend effector and bend your... Oh, your bend effector isn't going to work because I can see that your effector height is, it needs to be up here at the top of your mesh. It's only going to bend from the base to here, which is below our weight map. Increase the length down there in your properties. See how that little, as you increase it, and I'm not sure, yeah. There you go. Maybe a little too high, but that'll get us going. Cool. Change the angle. Oh, you're in setup mode still. I apologize. Yep. Yeah. There's one additional thing that we need to do. Now you're bending the entire mesh, right? We want to use that vertex map to influence the power of the bend. It's a simple change. We need to go to the actual deformer itself. And instead of under the type property, we don't want to bend the entire mesh. We just want to bend, keep going down, 2 more. There we go. We want to use a weight map. And then, well, which weight map? Right below it. Oop, right below, yeah, there it is. Yeah, now try, if you return to your effector and try bending your cylinder, see what you get. I can see it happening. Now just the rows that we highlighted are bending. So what is the power behind these weight maps? Why are we choosing to apply them?
It could, in the sense of the character rig, it allows you to make it possible for an arm to be jointed so that it doesn't just, I guess an arm is a bad example. I think a better example would be like a tail.
Yep,
And
okay.
this tail, it's jointed in a lot of places, and this allows it to move gradiently instead of like rigidly.
Bingo. Bingo. Okay. It allows us to bend across a gradient and to influence the shape of our mesh, more organically versus very rigidly. Okay. And it's non-destructive, right? At any time, I can go back in and change my weight maps and make an influence and have it influence the animation, right?
Does that essentially mean that you can set it up to work for a certain mesh item and then animate said mesh item in whatever way you want and have those keyframes stay, and then you can change the vertex map and the way
Bingo.
to do something differently?
Bingo, absolutely. That's exactly what we're going for here, right? We don't have to go back in and change, if we're finding that the deformation of our character is just wrong in certain areas. And you'll see this when we start doing characters, right? Elbows and knees are actually kind of a tough part of our body to rig, right? Because if you're not careful with your weight maps, you'll get like a little point coming off your elbow, right? And it's just a bad weight map, okay? Instead of having to go back in and reanimate the arm, we just go back in and change the weight maps, which is going to change the deformation in that area. You're up and running, okay? It's a wickedly powerful system, these weight maps. You're going to see these in many, many places going forward.
Can you apply like multiple weight maps to
to, yeah, absolutely, yep, yep. But each deformer can only get piped into one weight map. So we can have as many different weight maps on one mesh as we like, but this, see this deformer, each deformer only gets one weight map to modulate its influence. But I can have 80 weight maps. I can have a weight map for each row of this if I wanted to on this one mesh item. We're not limited there. All right. So let's talk about, okay, here's what I'm going to do. Just to make it really easy and really obvious as to what's going on, I'm going to deactivate the influence of my weight map on my bend deformer. I'm going to go back to entire mesh. Okay? That way, it's not looking at the weight map. It's just going to bend from the top to the bottom. Okay? Let's test it. Yep, looking good. That's what I'm after. I'm also going to change my viewport shading style back to default. And I'm going to turn off the visibility of my weight maps in my active meshes section of my viewport properties. Here we go. All right. One of the cool things behind about deformers is that we can stack them on top of each other. We can add multiple deformers to a singular mesh item. We're not limited to how many deformers can work and bend this shape a little bit, which kind of speaks to the power of this entire system. We're not just doing one thing at a time. We can do like 8 things. Okay? And let me show you how this works. I'm going to add a deformer that you guys are going to love. Some people are going to hate. Some people swear by the lattice deformer. Some people hate the lattice deformer, but it does have a role inside of our rigging system. Let me show you what it looks like. Now, I'm going to add a new deformer to an already deformed mesh. So I'm going to go into the setup, turn setup mode back on, so I can make some root changes to this rig. Now, once again, I need to be in item mode. I have my cylinder selected, and you can see down here at the bottom, we have the lattice deformer. Now, I like the lattice deformer. It can do some really cool things, and you'll see here in a second that it's going to create kind of a 3-dimensional grid that's going to go around, that's going to surround our object, and we'll be able to pull the intersection points of this grid and continue to deform our character. Okay? Let me show you what that looks like. Let's just add the lattice deformer in. You'll get this little popover. Okay, this is determining the resolution of this grid. I'm just going to leave it at 2 on the X, 4 vertically, and then 2 on the Z. So this is creating a little grid for us. And then when we hit OK, you can see that grid surround our shape. So we had 2 going along the X, 2 going along the X-axis, 2 grids going along the Z, and then 4 vertically along the Y. Okay. Now, what does this do for us? Let's exit setup mode, and I'm going to return my bend effector to a value of 0, just so we can start to see what in the world this lattice effector is doing. Now, if we examine the item list here, things are getting overwhelming, because what they give us is a locator for each of those intersection points, and we can select them here if we'd like. That's not very fun. Okay. They've intentionally kind of buried it underneath its parent item, because we don't want to have to go in and select each point from the list. You can actually do it over here. I'll hold down Shift, see if I can grab, or I'll just do a box. Don't want that one. Okay. Now, with those lattice deformer points selected, I can fire off the Move tool. You can see what I'm doing now. Okay. I'm not grabbing individual verts. Okay. I'm grabbing these deformer points, and it's bending and deforming my mesh based on the cage. Okay. Which allows us to do some really, really cool things. Okay. So, for example, I can grab these down here. Same thing. Oops. Let's see. What didn't I select here? Let's try that again. I don't know why it's not doing that one. Does that have to do with the weight? Oh, it may have a lot to do with the weight. Let's go back in and double check these things. Oh, yeah. Yeah. It automatically piped in that weight map. Great catch, Sue. Yeah. Let's just let's get rid of that. Let's put this to entire mesh. Now we can move these things around. Yeah. And we're on our way. That would be a shape, traditionally, that would be pretty challenging to model. right? But using a lattice deformer, I can get there pretty quickly, right? It's a great way for us to softly go in and change the volume of our object into something that's more complex. It's a pretty neat system. Yeah?
Is there a way to just then convert the mesh to not have the weight mass?
Yes. Yes, there is. It's not something that I traditionally would recommend that people do. This is a point of no return. When you freeze your deformations, it can get kind of scary, but you can do it, right? This is like the windmill in Back to the Future Part 3, okay? If you're not sure of what you're doing, you're either going to the future or you're, going to crash in a fiery explosion. I'm not, that rumor or that announcement comes out like every single year that they're making it like a Back to the Future Part 4. I say, cool, I love the Back to the Future cast, but they're all pretty old right now, right? I mean, Doc Brown is moments from death, right? So I'm not sure if, I'm joking, I think he's in the 70s, but point being, it's not going to be the same experience. And do we need another Back to the Future movie? I don't know. I kind of felt like that story was told.
Follow the same, like if you watch them back to back, they all kind of follow the same general plot structure. And I feel like if they try to do another one, they'd either try to do something entirely different and everybody would hate it, or they would do something the same
And everyone would hate it. Yeah.
So,
Yeah. This is the
solid trilogy, leave it as
this is the loop that you get into when you start to do reboots, right? Yeah. Anyways, okay, let's go back to our deformers here, okay? Because these lattice deformers, incredibly powerful, and here's a cool idea. You can animate the location of all these points. Ah, awesome. That's pretty neat. It's wicked powerful, right? But maybe what I want to do is that I want to have this shape and then bent 90 degrees, okay? I want to have both of them working in tandem with each other. Let's go back to my bend effector and change its angle. Oops, to not -0, that doesn't make sense. To 90. Yee. Ooh, that looks pretty poor, okay? That's not exactly the result that I was looking for. Ultimately, what I was after was that shape. Let's see, actually, hold on one second. Which way am I bending this? I'm bending along the y-axis. Let's see, let's bend it along the x-axis, z-axis. Oh, that's even worse. Let's go back to x. Okay, so really what I want is I want to have that shape, but then bent like an elbow, okay? I want that shape or maybe bent the opposite direction, okay? I don't want it to, well, for lack of a better word, oops, do that, which looks nothing like my shape, okay? One of the cool things about working in deformers is that, well, it is a computer-driven deformation system. Computers love instructions. All computers, except for the artificial intelligence ones, which are creepy, right? All computers are going to follow a sequence of instructions, and they're not going to deviate from that sequence. There's an order of operations that our deformation system is going through, okay? And it's kind of fun to see and edit that order of operations in our setup tools. So there's one small extension that we're going to make here to our Moto interface, and I honestly don't know why they turned this tab off. It's the most useful part of our deformer system. It used to be just chilling up here. So items, shadings, groups, mesh ops, assemblies, audio. What we want, I believe it's under data lists, is that we want deformer list. Okay, so I'm going to add a new tab to this part of my interface. So hit the little plus sign, data lists, deformer lists. Okay. Now on the surface, once you add it in, you're like, cool. It's just showing me all the deformers that are chilling in my scene. But it's more than that. This is determining the deformation order. Okay. If you look carefully here, like all things in Moto, we start at the bottom, we work our way up towards the top. Which of my two deformers are going to be fired off first? The bend deformer. So the computer is bending my cylinder 90 degrees, and then it's doing all that lattice deformer stuff second, okay? I want to flip it. I want I want the computer to evaluate all the changes that I made to my lattice deformer and then bend it, okay? We can reorder this list simply by left-clicking and dragging the deformers into the order that we want. So I'm going to grab my bend deformer, and I'm going to drag it up until it's above, come on, there it is. Okay, so lattice is going to be fired off first, and then we're going to bend it.
That was cool.
Was it cool?
Mine was like kind of jacked up, it messed up the polygons.
Uh-huh.
I clicked that, it fixed it.
It fixed it, right? Because now, let's see, in this particular example, let's just see how it works. Yeah, it's still kind of doing it a little bit. Yeah, this may not be the best visualization of what's going on, but we're not getting it all wonky and jacked up like it was before. We're lattice deforming first, and then we're bending it along 90 degrees. Let's see if I can get a better example. Yeah, this is a better example, because we weren't getting, I'm now bending it along the y-axis, and you can see that we're still preserving all of my lattice deformer stuff here, and then we're bending the entire shape along the y-axis, which is pretty rad. Okay. Our deformation system is wicked powerful. It's pretty sweet, okay? So add this deformer list into your setup layout, because this will allow us to influence the order of operation that all of this stuff is going to be fired off. It's pretty cool. So if we project this a little bit going forward into the future for our homework assignment, how can we use these deformers to get the result that we're after?
Lattice to bulge the ball, for instance.
I love it. Absolutely. Right? Yep.
Yeah, all the way up to the
Cool. You can use a lattice deformer to physically create the illusion that things are bulging. Okay. If you look carefully over here, I'm not going to go through all of these. There's some really good ones. The transform effector will allow you to do really simple squash and stretch, because now we're doing position, rotation, and scale on a deformer. We're going to talk about the morph here in a second, which I think you guys are going to like. The Bezier and spline deformers are pretty neat. If you've ever had to do like tubing, well, let me show you this. If you've ever had to do tubing, you're probably going to curse me a little bit here, but that's okay. Let me just make a new project file.
Wait, are you saying that there's a way to make a tube where you can take the tube points and then move them?
So, yes. This is just a new cylinder, right? New cylinder. I got my cylinder selected. Let's just do spline, because it's really easy to see what's going on. You'll get another little interface here. Let's just do 3 points along the x-axis, and I always put 1 meter in here. If you leave it at 0, all of these points are going to be collapsed at the origin. It's going to be impossible to select, and it's going to be impossible to edit. So I just kind of put 1 meter in here with the idea that I can go back in and change it in setup mode. Now watch what happens. Okay, there they all are. Oops, I did it along the wrong axis. Let's do that again. Spline along the y-axis. There they are. Okay, let's go into setup mode real fast and change the location of these effector points. If I can grab one. So I just hit the move tool here. There we go. Okay. So if I exit setup mode and grab one of these points, I don't know why it's not letting me do it interactively, but whatever. So sorry. Because now I can go in and change these and keep going. And it's pretty sweet. It's pretty sweet. There's another one, and I always forget, and again, I'm sorry, but I had to, if I give you everything on day one, you guys are just going to melt, okay? I always forget the order of operations, so bear with me just for a second. I'm going to grab the polygons on this thing, rotate it 90 degrees, and I'm just going to globally make this thing a little bit, not that way, oops. Hold on a sec. That's what I wanted to do. Just make it longer. Okay. Now, I got to remember, I think with this one I have to have a couple locators already in here. Yep. And I always botch the order of operations here. So locators first, then the item. No, I messed it up. This one, that one. The Slack one's neat, and I'm botching it here. I'll have to go back and look at the documentation, but it basically kind of adds this illusion of gravity into your like your wires, and the tube will be, maybe my locators are just too far off. Yeah, it's pretty sweet. I'm just not getting the selection system correct here. But you know, it will bend my little tube in between those 2 points. It'll make it look like it droops. It's pretty cool. Yeah. Actually, let's go in. This is a good question, or you know, a good problem to run into. Because 9 times out of 10, you forget something. It's not about knowing everything. It's impossible to know everything, right? Impossible. What you do need to know is where to look, right? Where to look to find all your answers. And luckily for us, the Foundry has a really great documentation system. Okay, so let's just open it up, local docs, and I'm going to search for Slack Deformer. Oops, I saw it a second ago. Let's do Slack Effector, excuse me. All right, here we go. Okay, item list. All right, here we go. So deform items you set up properly beforehand to produce the result. First, the target item should be long and skinny in nature, such as a rope, and be a single mesh item. Check. Second, position 2 additional locator items at each end. Yep, got it. To automatically connect the effector to the target, select the items, right-click. Oh. So I got to right-click. That's right. Add mesh operation. Yeah, this one's funky. All right. Add it under effectors, Slack. I don't think you have to do this, but let's just roll with it. Add mesh operation. Deform. Oh, wait. Deformers. Slack effector. Did it work? No, I don't think it worked. I'm missing a step. Hold on a sec. So this is where you go to find your answers, right? Oh, that's right. They're in groups. That's right. And then you add these. You actually just drag them into the group. That's right. There it is. I forgot that it works off a group idea. The whole idea is that you move these, and it kind of works. I think the setup location, let's go into setup mode, change the location of that guy, and the location of that guy. Go. Yeah, there it is. Now, wherever these things go. Pretty cool, huh? Yeah. And you can animate these too. I did this once on a couple models where I needed to have like ropes and stuff hanging down. Made it go really, really fast. Because actually modeling, modeling ropes like that, I know it seems kind of silly. It actually takes doing that, getting a believable kind of bend in there to look like gravity's influencing is not a trivial thing, and this allows you to do it pretty fast. So it's the power of deformers. It really is. And you can freeze all these down back into your mesh. It's not something, generally speaking, that I recommend that people do. But if you're working in a game art pipeline, or you're going to be popping these things out to another app, you're going to have to do it eventually. And you just freeze your mesh. And in here, let's see, yeah. So we just want to freeze the deformation. We don't want to tessellate it. let's just do that. And now, let's see, what did it give me? Did it do it? I may have hit cancel on accident. Nope, now it's all frozen. Yeah, and it froze the location of those deformers on the actual geometry. Yeah. Usually what I do is I kind of duplicate things first. So I always have a master copy that I can go back to in case I mess up or I need to change my mind later. But it's a great way of working. Okay? Say again? No, you can't. Yeah, this is a point of no return. Once you freeze the mesh, the influence of those deformers is gone. Okay?
Save and then test it?
Yeah, save, test it, save a new version of your project file. Usually if you're trying to bake your deformers or freeze your deformers, it's probably more than likely going to be the last sequence of your modeling stage. So it's a good opportunity to do file save as, or you can duplicate that hierarchy, then freeze it, so you always have a copy inside of your project file that's working. And that's unfrozen, that's thawed? Is that, I don't know. I don't know. All right, I'll tell you what, it's 10:45, let's just take a small little break, okay? A little 10-minute break and we'll get started, okay? Okay, let's get back into it. So I wanted to spend a couple seconds here just talking about my thinking whenever I'm going into modeling a new project. Now, this is the banner image from our homework this week, and I chose this banner image very specifically because in every sense it represents concept art, the kind of the totality of what we get as 3D modelers. Sometimes we're just given a simple illustration, and our job is to make that into a 3D model, a 3D rigged animatable model, right? That's kind of a lot of times those are our marching orders, right? Take that and make it into a 3D model that we then is rigged and is animatable, okay? So what are some of the concepts behind the construction of the model that we need to pay really particular attention to? Kevin, I love your hand signals. What do those hand signals mean? So considerations. What should we be thinking about before we jump into the construction of the model? I like it. So which parts are moving, which parts are not. For us, let's define what those moving parts are going to be. So the wheels are going to need to move, right? We're going to have to move. I love it. I love it. So we're going to need to have some sort of mechanical system that allows the wheels to move in reference to the body of the cannon. I like it.
Visually thought that what we were going for here is to kind of have like your cartoonish, like the barrel of the can's going to like pull back and the back's going to like bulge up and then it'll kind of
yeah, I love it. And that's where we're going, right? We're going super cartoony with this animation, right? So we're not trying to make a realistic, kind of interpretation of how a cannon would blast. We want to go super cartoony. So, a great opportunity for us to apply those, that great squash and stretch idea that we've seen in other classes. We'll talk a little bit about that here in a minute. So the orientation of the barrel is going to be important for us, right? Because we're going to need to create a whole series of rigged elements that understands the local orientation of that barrel, okay? So that's important. What perhaps would make it easier for us is if we model all of this information kind of globally around the understanding of the XYZ axis, right? So I'm not going to model a barrel up at an angle, right? I'm going to try to model that barrel how? You got it perfectly, kind of perpendicular to the XZ plane. So I'm not going to model at an angle because that's modeling that's going to be tough, rigging it's going to be tough. Let's make it easy, have everything at 90-degree angles to each other. And then we can animate it and move it into whatever position and pose we want.
And so we made a cannon in 402.
We did, which was not this and not cartoony.
No, but it is. Would you recommend it is a viable model to use the deformers on to make it animatable?
Absolutely, for sure. For sure. Yeah, as I said earlier, if you haven't taken GCOM 402, use any model that you can find. Use those mesh presets that we talked about last week, okay, or a couple weeks ago. That's absolutely fine, okay? I'm really okay with that. Or you can make another one. And luckily for us, something like this is going to take about 5 minutes worth of modeling work for us to get us up and running, okay? So we got to pay attention to the wheels. We got to pay attention to the orientation of the body, okay? Now for mine, another thing that I'm seeing almost immediately off here at the moment is that the back of the cannon just comes to a really nice spherical shape, okay? So I want everything to kind of terminate quite lovely as a sphere, which is different than how it terminates for a cylinder, which is going to be a flat top. So we're going from a sphere, kind of a bulbous shape in the back, to more of a cylindrical, barrel shape in the front. So I may have to have two different construction pieces in play here to get the shape that I'm after. One of the things that I always try to consider as I'm starting a modeling process are how all of my forms are going to terminate and end. Because usually if we have a good vision of that at the beginning, that will lead our first step. I want to start with a sphere, okay? Since this termination point way over here at the back is important for me, I'm going to start with the sphere. Okay, I'm not going to start with the cylinder. I may join a cylinder into the mix here, but initially I'm going to start with the sphere. Some other details in here that I want to be very mindful of as I go through this process. I love these little detail pieces, these little rings that wrap around the outside of the mesh. I want to keep that in there, right? If you look closely at what the concept artwork is establishing, is that they are the exact same width, okay? So that's something I'm going to be thinking about as well. How can I create some geometry 2 different rings of the exact same side that match the curvature of my cannon base. Okay, interesting idea, something that we can solve pretty quickly. Okay, and then for the back, you know, the little fuse thing, you know, if we have time, we can look at that. That's a detail. I'm going to see if I can start flushing out real quick the base of our cannon. Okay, so one of the things that I see people skipping in their modeling process is really understanding scale, how big this thing is, right? For me, that is literally the first step, is an understanding of the total volume that this thing is going to be, okay? All of our 3D systems, both in Modo, Maya, Cinema 4D, Unity, Unreal, work off of an understanding of scale, especially when we're working with rigged components inside of Modo, right? Distances now become a factor, right? Specific rotation degrees now become a value that we're going to have to manage, right? So making sure that we're modeling to scale is critical. So let's figure out how big this cannon's going to be. I'm going to open up Mesh Preset Library, and I can't tell you, you know, I use this base sculpt male on every project, right? Because what's the average height for, you know, a male character? Does anyone know? 1.8. Yeah, it's like 6 feet. Right? In my mind, it's just 6 feet. That's a value that I can understand pretty quickly. I'm 5'7", so 6 feet, a little bit taller than me. I now have a relationship, you know, that I can understand in scale. So here's what I do, okay? You know, I'm in my preset library under the Meshes Human category. If you just double-click on that, it loads it into the scene, okay? So now we get to ask the question, how big is our cannon going to be in reference to the human being, right? Let's get it into real-world scale, because the dimensions of this guy are already established. If I select him and fire off the dimensions tool, yeah, what's the saying? 1.82 meters, okay? And if I ask Siri, I'm sure she can give me the values to that, but I'm not going to do that, okay? It's about 6 feet, okay? It's my favorite part. That's how I use Siri almost exclusively. It's like, Siri, convert 100 millimeters to inches, and then she gives me the value. And I'm like, thank you. You know? Always say thank you to your computers, right? Because there will come a time when they're going to control our destiny. So I think it's good that we start reminding them that we thank them for their service now. You know, I try to get on the good side of people instead of the bad side of people.
You don't want to be the person that pisses off the
Right?
robot with the plasma.
Yeah, exactly. Yeah. Okay, so how big is my cannon going to be in relationship to this object here? That's the big question. And I think, let's see, let's just throw some shapes down. Now, I'm not paying attention in this moment to how I'm doing this. I'm just thinking about scale. If that's the barrel of my cannon, that is a huge barrel. Okay, that's like a mega cannon, right? I think I want the barrel to be a little bit smaller, somewhere right around in here. How big are the wheels going to be? Okay. Let's center this on the X. There we go. How big are the wheels going to be? I don't know. Let's find out. Let's do some basic shape exploration now when all the geometry is wicked easy. I don't care about the construction practice at the moment. I'm just trying to figure out size and scale. Maybe that's a little bit too much. If that's going to be my wheel. And let's just shoot. Let's just prototype what this potentially could look like. Okay, so if that's the back, I am pretending here. Okay, and it's okay to pretend. This is just the exploratory stage in all this. Yeah, that's, let's just call that okay. That's a good place to begin. Okay, now I no longer need my base mail, but I am going to keep all this other stuff. I'm going to cut and paste it onto a new mesh, get rid of my base mail, and there we go. That's my basic blockout shape for my cannon, right? Just an understanding of scale, how big it is. This is approximately how big I want my cannon to be, okay? If you get it into these real-world scale values early on, believe it or not, the rest of the modeling sequence gets a lot easier. It gets a lot easier. Because now you're not having to say, you know, because sometimes when you like do an edge bevel, for example, okay, you know, all of these values here are real values. So where it's actually making a 12 millimeter radius, okay? If you were to change your unit of measurement over into inches, you can say, oh, okay, I'm rounding this out about a half an inch. That's something that in, that we can have an understanding of out here in the real world, okay? Does anyone remember where to go to change all of their unit of measurement values? Yeah, it's in your global motor preferences. And then it's down here towards the bottom, I think, under input. Yeah, units. Let's do English. Now we're in feet and inches, okay? I prefer to keep it in metric for as many things as I can. It's just easier, right? Now we can see that I'm just rounding out that radius to a value of a half an inch, okay? It makes it go a little bit faster, a little bit easier. You can understand it a little bit more directly. I saw the best meme the other day. It's fantastic. This was actually a couple months ago now, when the government closed down for a day. Do you guys remember that? The government shut down for like a day, right? Because Congress couldn't decide on budgets and all that jazz. And the meme was, quick, well, the government shut down, change everything to metric, right? Because metric is so much better than this feet and inches, fractions of an inch, right? Can't you just tell me the value like they do in metric, right? Anyways, okay. All right, so now that I have a really good understanding of scale, I can start fleshing this out a little bit, okay? Earlier I mentioned that I want to use the back side of my mesh as, or I want to have it be a sphere. So I just added a unit primitive sphere into the scene here. And if you're going to do this, you need to be really mindful of the pole, okay? And this is the pole way up here at the top. Let me turn my wireframe colors back on. So this is the pole, okay? This is where the sphere, all the edge loops, all these spans, terminate up here. So we need to be very mindful of that, right? Usually the pole needs to go at the rear or at the front of whatever object it is that we're trying to create. The pole is something that is difficult to manage topologically. So what I'm going to choose to do is just rotate this 90 degrees, okay? So this is going to be the back, okay? And I think, yeah, I'm just going to cut off about half the sphere. And how many edges did I use? So this is a 24 edge cylinder, or a sphere. That's a pretty good place to begin, okay? Now the cool thing about working with a sphere is that if we were to close the selection, we now have a shape that we can continue to bevel, okay? There we go. That looks pretty good. And I think what I'm going to do here is that I'm going to leverage the power. Let's put my reference mesh back in here because I've already gone off reference. But that's okay. Somewhere, let's do somewhere right around there. Yep, that's good. That's a good place to begin. This is how long I want my cannon to be, somewhere right around there. Okay. So now I could go in if I wanted to, and I want to create, a cool little taper and then maybe a nice little bell at the end. I could go in and do that by hand, but Pat doesn't do things by hand. That way it takes way too much time, and the results are going to look very man-made, and that's going to look inconsistent. There's a more accurate way of getting some nice deformation and curves inside of these forms without having to do this, okay? And you guys have done this, okay? It's a pain in the rear. You loop slice, okay? Maybe do like kind of 3, and then you go in, you grab each loop, scale it down, grab the next one. Have you guys done this? Yeah, that's no bueno, right? That's not fun. There's a better way of working. There really is. Yeah?
Does it kind of look like a new when you look at it?
It does a little bit, yeah. If we start to include some of the ideas that we talked about earlier in class, we can get some really great results if we incorporate fall-offs into our modeling sequence, okay? So check this out. I'm going to do a loop slice one more time. I'm going to add 5 in there, okay? Uniformly spaced, okay? And now what I'm going to do is that I'm going to grab all of these loops. So you always make your selection first. I'm going to look at my scene from the right. Check it out. Let's add a linear fall off. And back over here, I don't really want this edge loop to change. Or actually, I want to start my deformation from right in here at the conclusion of my sphere. So this is going to be 0%. I left click and drag. this is going to be 100%. Okay. Now, if I fire off the scale tool and simply do this, now we can create a cool taper, which is already markedly a whole lot better, right? We're doing a massive edit. That fall off is allowing me to make a sweeping change across all the selected edge loops. It's modulating the influence of the scale tool. Down there at the rear, that first selected loop on the right, it's only getting influenced, oh, I don't know, 10% of my scale operation, 20%, and so on, right? Way over to here to this top one, which is getting 100% of this 54.5% scale, okay? That's neat. That's pretty cool. We can make it better by going in and examining some of our fall-off properties. Check this out, because this is really the bee's knees. I love this, okay? Check it out. We have a shape preset down here that's pretty rad. Right now, the default is linear, and this is what we're getting, a linear gradient of influence across the fall-off. However, if we change the shape preset, while the tool and the fall-off are still live, check it out. Here's the ease in. That's cool. Okay. Here's the ease out. That's cool too. Smooth kind of does both sides, and I think that's what I'm going to choose to do. Okay. So now we're starting to change the shape based off of these shape presets, which is a good place to begin. Let's turn off my mesh, and that's a nice consistent kind of curve. Yeah, I'm in the modeling layout at the moment. Yep. Yeah, I'm not animating it. I'm just changing the geometry with those fall-offs. So these fall-offs play a really big role inside the larger context of Modo as a whole. It's not just a setup tool. It's just a tool. It's a global influence across the entire application, which is pretty rad. Now, I'm not going to go much further in this. Let me turn off the influence of my fall-off. Okay. And let's do it. Let's do this. Let's see if we can create a cool little bell shape in here. So I want to bevel that shape out. And now I need to figure out how I'm going to deform that in a way that gets me the result that I'm after. So once again, I'm going to loop slice. I'll put a whole bunch of geometry in there, count of 5. And I'm going to go in and select all of those edge loops. Okay. Now I don't want to mess up all of this stuff to the right over here. I just finished that. I really want to focus my energy on this shape in here to see what I can get. So let's add the fall off again. 0%, 100%. Okay. Let's fire off the scale tool now, see what we can get. Sometimes just experimenting and playing around with it gives you a really fun shape. Yeah, look at that. That would be a pretty difficult shape to model quickly. Okay, look at this curve, because it dips up, if you will, and then it dips down. It's like an S curve in there along the profile shape. And I did that all because of the fall off and the shape and the smooth shape preset. Point being, these fall offs give us a tremendous amount of control. They allow us to globally affect the influence of a tool across all the selected components. Okay? And I think I'm going to say done. That's good enough for me. I like that. That's a fun little cannon, kind of cartoony. I'm going to turn off my fall off, and let's just give it some handmade info. Let's do this. I'll kind of stair step down, and I really want it to be big in here. Go, and I need to fix this interior geometry. See how it's poking through on the top? That's okay. I can always just go and fix it. I'm going to grab that loop, and then in my orthographic view, just going to slice it here. Now at times, this is where it gets kind of fun. I'm trying to select the thing that you want to edit. Is that it, or is that the right one? Yep, that's the right one. There it is. Now nothing's poking through. Life is good. Happy campers. One other thing that we have to be mindful of, since we're now working with rigged components or future models that are going to be rigged, okay, is that n-gons are something that we really, really need to take some consideration in resolving. If you hit the tab key, of course you're going to put this mesh under the influence of the subdivision surface algorithm. But this down here, this little star pattern, is a good indication of what the deformation system is going to try to do, right? Because if you think about it, when you hit the tab key, the sub-D algorithm deforms our mesh. It puts all the surfaces under tension and starts bending our geometry a little bit. And this deformation down here is not good at all. It's uncontrollable. Larger point being, no n-gons, okay? In the deformation world, if something's going to be part of a rig, it can't have any n-gons in there, okay?
So in this case, would you want to probably unsubdivide it to edit it and then go into that circle and just slice it up?
So let's talk about what we can do in here, and that's the end result. We're going to need to put geometry down there at the end of the cannon one way or another. There's a couple different ways we can do about this, and this is going to take some experimentation. It really is. Not all solutions are going to give you, the answer, right? So a couple ideas to throw out there. First and foremost, in your polygonal tool set, there's a great one called Spiky. Okay, here it is right there. What Spiky is going to do, let's see if I can do this. So Spiky, there it is. Now watch my shape as I run Spiky. Boop. Clicky click. What did it do? Made a bunch of spikes, made a whole series of triangles, right? It looked at every single vert going along the circumference of that circle, and it drew a line from that vert to a common center point in the center. Okay.
Does that work with other n-gons? I'm assuming it's kind of case to case based on the.
It's very case to case. Yeah, very case to case.
Before knowing about this tool, I would have gone the long route and done an edge slice. It just would have taken like 20 minutes to get through all that.
Let me show you another alternative, because this is a good one. Spiky is a good one, but it's going to give you a whole lot of triangles. Our deformation engine, in all apps, really doesn't like triangles all that much. Triangles are kind of a no-go for us. If we can avoid triangles, let's avoid them. Ideally, quad polygons are the way to go. So Spiky is cool, but let's look at some other alternatives. Okay. Now, the next alternative that I'm going to do, I'm actually going to delete that polygon and grab an edge selection. So I've made an opening. If you go into the edge collection of tools, there's some good ones in here. Check it out. It's an option called Fill Quads. I'll get a little pop over here. Fill with the grid pattern. Okay. Don't have to slice it all up. It just does it for you automatically. I just blew someone's mind. Adrian is, I can see his, I can see his brain popped out of his ear, jumped on the floor, and ran out the door, right? Yeah. Yeah, fill quads is good. One thing that people forget when they're working with fill quads is, believe it or not, this little option, with it off, you may not get the best pattern. It is going to slice it up. This is actually pretty good. They're all still quad polygons, but the grid pattern, this is far superior, because this is going to give us a more deformable mesh back there at the rear. Okay, so keep that in mind. Fill quads, I use fill quads all the time. It's a great option. It doesn't. For planar surfaces, it's going to give you a nice series of quad polygons pretty easily. If it's on a curved surface, maybe, okay, you'll have to look at it a little bit more intensely, but it's definitely the first look for me in a lot of ways. Okay, so now that we have all quad polygons, except for back here, okay, and triangles aren't horrible. Those are all triangles there. Let's actually do this. What do we get if we do a fill quads back here? Yeah, that's pretty good. Yep, that's not so bad. I think I like the triangles better. So I'll hit undo. Yeah, I get a little bit of a star kiss pattern back there, but I think for brevity's sake, just to keep going, I'm going to leave it as such. Okay. Now another thing, since I'm me and I can't not do it, if you look at the transition, this is Pat's kind of modeling trick of the day. You want to be very mindful of these plane changes as 3D modelers. Okay, if you look very, very carefully at the profile of my barrel on the cannon, we're going from a pretty intense curve here, and then it terminates and changes its angle very sharply going inwards. That plane change kind of doesn't work. It's not really realistic. You don't see that kind of plane change happen out here in nature, okay, or out here in the real world, okay? So we need to kind of start to modify and influence that plane change to make it look a little bit more believable. Simple little radiuses, okay? I'm just going to do an edge bevel. I want to put my round level to 0. Simple little plane changes like this go a long way, because now if you look carefully, we've changed the direction of all the polygons. They were going out and then cutting back 90 degrees to make the front of the barrel cannon. Now they're going that same angle, but then, because we did that the edge bevel, they're going inwards before they terminate and go flat. That little plane change helps resolve sculpturally, if you will, helps resolve this entire shape down into something that's a little bit more believable, okay? Drop the tool, take a look at it. Yeah, that's sitting pretty. Hit the tab key, turn off the wireframes. That's a good place to begin. It also gives you a tremendous amount of opportunity to go in and either add additional edge loops to make those areas tighter or not, or if you're not going to subdivide it, maybe you keep moving on. Now, I'm a big fan of sub-Ds because Pat don't like polygons, okay? But I like hard edges at those plane changes. Now, up here at the front, check it out. Let's turn my wireframes back on. Up here at the front, I really like that edge and that edge. I think that's pretty cool. I really like the angular nature in here. I think it's getting smoothed out way too much. So I could go in and start adding some more geometry in here. Just doing loop slice. Count of 2, mode of symmetry. I could start adding some edges in here. Yeah, see how I'm tightening it up now? That's pretty good. Actually, I really like that. But what it's doing in turn is physically adding more geometry into our mesh. At times, we don't need to add more geometry. Now, buyer beware. What I'm about to show you is a Modo-specific modeling process, okay? If you're designing something in Modo and modeling it for a game engine, you're probably going to have to add geometry like I've done here. But if this model is staying in Modo, it's going to be rigged in Modo, animated and rendered in Modo, you can use edge weights to help you resolve some of this stuff. Let me show you. I'm going to go back in time. These two new edge loops that I've created in here are basically reducing the influence of the sub-D algorithm across this plane change, okay? I can do the exact same thing with edge loops, or with edge weights, okay? So I'm going to grab both of those edge loops. Now keep in mind, I've just deleted those 2 interior edge loops that were created with the loop slice command. So we're kind of back to the original form here, okay? I'm going to hit the tab key, and believe it or not, if we go back into the Vertex Map Pulldown menu, here it is, edge weight tool. Check it out. Isn't that cool? I'm just left-clicking and dragging, which is changing the percentage of the edge weight, okay? What we're actually doing here is creating some vertex maps. There we go. Pretty neat, huh? Some vertex maps, and we're changing the weight of those verts along the map, okay? And it's influencing the sub-D algorithm, okay? Now, what that's doing for us sculpturally is that we're getting almost the exact same look, but without adding any more geometry into the scene, okay? If I know that I'm going to be keeping my model inside of Modo, I try these edge weights first, okay? Yeah, check that out. I try that first before I start going in and adding a zillion small little edge loops to shore.
This seems like it would be really helpful when you're trying to have a mesh that you want subdivided that has a lot of weird angles that
Yep.
you're not going to be able to because
Yep.
a lot of projects last semester, when I wanted to have something subdivided, you go through and try to do edge bevels,
Yep.
do loop slices, and sometimes times it just doesn't select the right
Yep.
things and puts them in weird
Yeah, the structure of your mesh often determines how those edge loops are going to be inserted, which is going to ultimately influence the result.
places.
Yeah.
You can just select all the specific edges you want, and it'll usually just kind of do what it.
It's contextual on the mesh, but this allows you to start doing, it starts allowing you to influence the algorithm without actually adding more geometry, which can cause problems. Thomas and then Adrian had a question. Yeah.
So for the cannon, would it be okay to use like the one that's like ground earth, sort of ground into the earth, like
Put some wheels on it. I want the wheels on there. Okay. That way you can start to animate the wheels and practice the application of some of those revolve modifiers like we did earlier in the semester. Okay. Adrian, you had a question? Yeah.
So that's technically under the Vertex map.
Yes. Mm-hmm.
Do Vertex maps, like when you're exporting something dark blue, do the Effector Vertex maps not follow?
It depends. I know that's not the answer you were looking for, but it depends on the file type you're exporting and where it's going and what applications could be reading it. Over into a game engine? No. It's just not going to work. This is not something that's really supported, or subdivision surfaces at all. You don't see. I think the Unreal Engine has a casual understanding of sub-Ds. Unity, not even on the roadmap. If you're taking this over to Maya, yes. Okay. So it's kind of dependent. Say again? No. Yeah, not going to happen. I wish Substance Painter supported sub-D surfaces. If I was a betting man, I'd say probably in the next major release they will. Substance has been adopted probably faster than any other app out there by the visual effects industry. A lot of folks are jumping. Substance was originally designed for the game crowd, right? But their tools were so good that the visual effects crowd, the high-end animation crowd, also jumped onto that bandwagon pretty quickly. So it's only a matter of time. Yes?
But if you want to do something like this, can't you always, can you go into the game viewport and smooth it out or harden the edges?
It's similar. It's similar. But remember, we're not changing the smoothing angle here, okay? We're actually reducing the influence of the algorithm. So the visual result of all this, let's go back to default, okay? So when you're in the game viewport and we're hardening and softening the edges, we're not actually changing this shape, okay? It's always going to be that angle. We're determining how the smoothing, how the material smoothing angle is interpreted across the surface of our mesh. With these edge weights, we're actually changing the shape of our model. It's pulling, the algorithm towards these areas. Let me do it one more time. Like maybe I want that in there to be a little bit tighter. See how we're fundamentally changing the shape of the mesh? It's not a shader trick. There we go. Looks pretty good. Turn off the wireframes. Yeah, I didn't have to add any new geometry. I just changed those weight maps or those edge weights, excuse me, for the model, and the algorithm was updated. It's pretty great. It's pretty great, and this is something that's going to continue to flow down into our deformation system, which is pretty awesome. Okay, so use those edge weights. They're pretty cool. They're really easy to use. Okay, I really can't recommend them enough. Okay, that's a good little cannon. I may actually keep that. Now the last thing that I wanted to show you guys really fast were these repeating elements. Now as a modeler, those repeating detail things are something that we need to draw focus to. How are we going to do that?
You could go through and you could slice the sections and then bevel them out.
I like it. Slice and bevel. It's a great way of working. Okay. How else could we do it?
edge bevel and then just set them to 0, so it's just.
Yep, I like just an edge bevel. If you have the geometry in the right spaces, that will give you the result, a good result. How else could we do it? What if you don't have the geometry in the right places? You could deform it somehow. Okay. I wanted to kind of revisit the idea of Booleans. It's something that can be used very strategically to give you a consistent size in details, right? Because I want each of these bands to be exactly, and I mean exactly the same, okay? the edge bevel system that Liam was pointing out, it's a great way of working because each edge, if we did them both at the same time, whoop, it's going to grow a specific value. But what if we don't have edges where we want to put these details in, right? The Boolean system allows us to very quickly get what we're after. So let's do it real fast. I'm actually going to nuke all this stuff. There we go. Okay, so what I'm going to do here is I'm going to say that I want to have, this is the size of my band, and I want one there. So I want to make this true 3D geometry. So my cutter pieces need to go all the way through my mesh. Okay? So if that's going to be the size of one of my bands, maybe I want another one back over here. Okay? Right now, if you look at the location of all of my edge loops, there's an edge loop, there's an edge loop. I'm slicing in between them. So I want to add some interior structure here that'll give me what I'm after. Here's a great little moto trick. I need 2 of these cubes. Okay? How could I make another copy real quickly? Yeah, Control Shift, the duplication tools. Okay. You can copy and paste. So I can copy, paste, hit the move tool. Boop, I have 2. That works. I like this one. I'm so happy that it's in here now. If you fire off the move tool, or any transform tool for that matter, then hold Control and Shift, it'll duplicate it when you drag it back like that. Okay, that's a good one. That's a good one, Control Shift. All right, so now I got 2. Those are where I want them to be. Let's go back to the other mesh item that contains my geometry. And I don't want to slice the inside of my barrel. I just want to influence the exterior. So here's what I'm going to do. I want to tell the computer very directly what to grab. Right there. I just wanted to evaluate those polygons. Geometry, Boolean, solid drill, and I'm going to choose the slice operation. There it goes. Now I had my wireframes off and I'm subdivided, so everything's looking kind of strange. But in fact, it did do it. Oops. There we go. Aha! So there's the loop. There's the loop. And now I can simply bevel those out to whatever size that I want. And life is good. Okay. Hit the tab key. Everything starts to round out a little bit. Perfect, perfect application of those edge weights. I don't want to add more geometry in here. I always try the edge weights first, because 9 times out of 10, I can get the result that I'm after with edge weights without having to add any more geometry. That was the base. Here are the edge loops that define the top.
Why did you go to Boolean? Why didn't you just select, those edges, like polygons and just bevel?
Because I didn't have the structure in the right places. Yeah, I didn't have edge loops where I needed them for the bands to grow in the where specifically I wanted them. So that's why I chose to use the Boolean method. So I was using that geometry to slice in edges right where I wanted them to give me the structure I needed to do the next bevel operation.
Question.
Yeah.
Using the Boolean, how do you use it to cut away?
Yeah, so if you look at the different Boolean tools here, solid drill, I mean, there's some good choices in solid drill. I'm a huge, huge fan of slice, because that's all it's going to do is just cut some edges into my mesh. It puts me in the driver's seat as to figure out what I'm going to do next. However, if you look at it, there's also core and tunnel, which are going to do some subtractive, operations. But that's solid drill. If you're used to doing traditional Booleans like union, intersection, subtraction, that's there too. It's just a different tool, a different Boolean tool. It's this one. Yeah. So if you take a step back and look what I've made, seemingly that's a pretty high resolution Canon mesh, okay? But if you look at the actual geometry, there's not a whole lot there. Those edge weights are pretty magical. Yeah. There's nothing worse than having to deal with a mesh that's got 1,000 little edge loops that are trying to shore up the sub-D algorithm. It turns into a nightmare. in UV mapping, it's a pain in the butt because now you have a whole series of small little rows of polygons they have to manage. Those edge loops are pretty magical. Okay. All right, so I'm going to give you guys, we got about 45 minutes left in class. I'm going to give you guys the remainder of class to start working on this project. Remember the goals here. Let's actually revisit the goals on Canvas. Those some modeling ideas. Okay, so this is going to be due next week. Some ideas here that I'm looking for you guys to construct. Okay, rig a cannon model that allows for the movement of the barrel, the wheels, and some sort of projectile. I don't care what your cannon fires out. I really don't care. You're going to eventually animate this cannon firing something. It could be a bowling ball. It could be a rubber chicken. Do not care, right? Bonus points are awarded for rubber chickens. There are no bonus points.
What if it fires out a pebble?
Rock and roll. I say thumbs up, man. I'm all about that. Okay, it could fire out a car for all I care.
So we're just rigging it this week?
You're making the model. Okay. Some of you are going to choose to make your own model, which I think is an awesome idea. If you're not real strong in your modeling skills, use some of the mesh presets, okay? Those science fiction mesh presets that we looked at for our alien invasion rig, okay? Those are great places to begin. The rigging stuff is still going to be the same, okay? So you're going to need to, move into the barrel, move into the wheels. Projectile needs to come out using deformers and constraints, okay? Now, I want you guys to produce an animation that kind of goes through the entire cycle of what a cannon would look like, right? So we're going to anticipate the cannon firing off. In the context of animation, what is this anticipation going to look like? Take a guess. It's going to roll, maybe roll back a little bit before it fires something off. This is squash and stretch. Yeah, absolutely, right? The barrel maybe can squash back to anticipate it firing off, and then it go out. Yep.
Or like how it just like it moves back and then part of the backside just like expands and floats and then
Right, the back and then pushes out a barrel or pushes out a cannonball. I think it's a great idea, right? All things that we can very, very easily achieve in our rig with deformers, okay? It's all deformers. It really is. The lattice deformer is awesome.
Now, I have a quick
Yeah.
question for, on the last video,
Mm-hmm.
you created a target.
Yes, I did. Yep.
Okay. Now, how, is there a way that you can use, like, 2 cannons for 1 target? Or do
Yes,
you have to
uh-huh.
create another target?
No, they all can go to the same target. Yep, for sure. For sure, because each cannon would have its own directional constraint to that target. Yep.
Okay.
One of the things that we've talked about in another animation class is the wave principle, that we're not trying to linearly squash and stretch our object. The movement starts at the back, and then it goes through the front, right, like a wave. The squash and stretch should look like a big ripple going through our object. So, you'll see that you'll get that for free when you start animating your deformers, okay? Arcs, whatever you're firing out the front of your cannon needs to fire along an arc, right? What do arcs give us in the context of animation? Gravity, right? Okay, you're going to be hand animating the deformers to get the squash and stretch on the barrel and the cannon. You're going to be hand animating the projectile firing out of the cannon, okay? Yeah.
Is it possible you could go through the path one more time?
You could do the path constraint. You certainly could. You certainly could do a path constraint for the projectile. So I'll just use what I have here on a new mesh. And actually, you don't need it on a new mesh. It can be on this one. I'm going to create a path. In the modeling layout, the paths are hidden underneath the pen tool. Okay. So one click. Here, let's do this. It probably should start back here. Okay, there's my arc. At least it's an arc, right? Awesome. Okay. Let's go back over to the setup layout, and there it is. There's going to be my projectile. Okay. All right. Let's call this cannon ball. Roger. Let's go back up to over to the setup layout and start rigging all these ideas together. Okay. So that item. Oh wait, no. Excuse me. I need to cut that onto its own mesh. I forgot to do that. Let's name this mesh curve so we know what's going on. All right. So that item is going to get constrained to that item. So under the modifiers, path constraint. There it is. The ball's on the path now. And how do we animate the ball traveling down the path? Does anyone remember what? Huh? Path percentage, right? So we got to go find the actual modifier itself, which is docked underneath the cannon ball. There's the path constraint. Here's the path percentage property that we're going to animate. Okay? There it goes. You could do that for sure. You absolutely could do that.
Okay.
Yep. It's a great way of working.
So you put a path percentage, you put it to 100,
Mm-hmm.
and then for it to be on wherever you want it to be, on the ground, wherever.
Yeah, so if you wanted to, the termination point for your curve is going to determine where your cannonball is going to go, right? So I could just really change the shape if I wanted to. It's going outside the cannon, but just to prove the point. Personally, I would probably not do this, in all honesty, because it takes away from us being able to do some really great animation on the ball. Think about it like a cannonball, hit the ground, poof, roll a little bit, hits the ground and rolls a little bit. If you're putting on if you're constraining it to a path, you're not going to get that functionality. Yeah, hand animate the ball. Not everything has to be rigged. When you start in on the animation, start thinking about what you want your animation to look like, and make sure that your rig supports whatever it is that you're going towards. All right, so at least 5 seconds. Okay, at least 5 seconds. Don't go much past this. Okay, I don't want this render to kill you. We're asking you guys to render this at 1920 by 1080. Okay, it's important that we start to get into this 1080p rendering mode. Okay, so prepare for a long render. Don't make it shiny. Resist the urge to make your cannon shiny. What takes forever is shiny metal things. Okay, yeah. If you have a second, yeah, the reflection rays are what kills it. Okay, so don't make it reflective. Leave the specularity down pretty low. Keep it as defaults if you'd like. Okay, that's what's going to make these things really, really long. So prepare for. Don't do this next Tuesday. Try to get this rigged and modeled and ready to go over the next couple days, which will give you then the rest of the week to fire out a good render. Okay? Makes sense? Everyone sure what we're confident in understanding what we're trying to accomplish this week? All right, let's get to work. I'll download them and see where we are.